Hello everyone, my name is Harsh Masne. My SAP ID is 600011980004. Today I am going to present my second DLIC practical, that is application of op-amps as adder and subtractor. So I will implement these applications on LTspice software. So in this practical there are three parts, that is to implement a linear equation using op-amp, to design non-inverting adder, to add three DC input voltage, and to design a subtractor circuit. So first see the linear equation using op-amp. So the equation is given as V out is equal to 2VA plus 3VB minus 4VC. So here we'll require two op-amps. Both the op-amps will be in inverting configuration. So our output will be RF by R1 into VA plus RF by R2 into VB minus RF by R3 into VC. So the RF by R1 combination will be 10K by 5K, which is equal to 2, and RF by R3 combination will be 10 upon 3.3K, which is equal to the 3, and RF by R3 combination will be 10K by 2.5K, which is equal to the 4. So at V0 dash we will get minus 2 VA minus N and minus 3 VB. So it will get inverted, and also it will add the VC voltage. So at output we get 2 VA plus 3 VB minus 4 VC. So we'll implement it on LTspice software. So we'll take some of the VA voltages and see the output voltage. So let's design it on LTspice. We'll take two op-amps. Then we'll require resistors. We'll take standard resistor values, so it will be also implemented in hardware. Okay, so let's place it properly. So let's wire it. Okay, here will be a will connect a DC source. take the DC source. So one will be here, one here, and that camera here. We'll also require to supply voltages to the op-amp, so more to DC source. So let's connect it. We will provide the ground for all. So I think I have designed the circuit well. So let's compare it. Okay. So now we'll put the register values. So we'll take a standard value. So first 3.9K. This will be 1K. And this will be 100 ohms. So total 5K. Here we will take 3.3K. And we require 2.5K. Okay, so we'll take here 2.4K, and this will be my 100 ohm. Okay, so give us supply. Here we give 1 volt. This will be also my 1 volt. This will be also my 1 volt, and the supply 15. So just label it VCC, VCC, and VCC. We'll go for VE. Sorry for that. I have connected ground here. This will be my VE. Okay. So now we'll see for this condition: VA 1 volt, VB 1 volt, VC 1 volt. So output will be our 1 volt. So let's check it. Once more we'll check for it if any errors are there. Okay, so let's simulate it. We'll take a VA output, so it will be easy to visible. Okay, so let's simulate it. I think our RF register are running. This will be 10K. This will be also 10K, and this also 10K. Okay, so let's simulate it for DC points. So here also you can see the V out, which is 1 volt. You can also see it here. Okay, 1.03, which is approx 1 volt. So now we'll go for next stage, that is 5 volt, 1 volt, 2 volt. So we'll change it, 5 volt, 1 volt and 2 volt. Okay, let's simulate it. So our Vout is 5 volt, 5 volt. It is 5 volt. Now we'll go to the next circuit, that is to design a non-inverting adder to add 3 DC input voltage. So this is our circuit. So here we'll connect the 3 input supplies, V1, V2, V3 to the non-inverting terminal of an op-amp, and this will be feedback. So our output expression will be 1 plus Rf by R4 into V1 plus V2 plus V3 by 3. So here we will take R1 is equal to R2 is equal to R3 is equal to Rf 10 kilo ohm, and R4 will take 5 kilo, as our Rf should be greater than 2 times R4. So our output will be V1 plus V2 plus V3, as our this combination 1 plus Rf by R4 will become 3, and with this 3 get cancels, and our output expression will V1 plus V2 plus V3. So we'll check the condition for this, where V1 will be 4, V2 will be 3 volts and V3 will be 2 volts. I have already designed the circuit, so let's just open it and show you all. Okay, so you can see the R4 is our 5K, so I have taken 5K, then here 10K and the supply V1, V2, V3, and the RF resistor 10K. So let's change this. So our first condition is 4, 3, 2. 4, 3, this will be 2 volts. Okay, so let's simulate it. So our Vout is Vout. Okay, the Vout is 8.99, which is approximately 9 volt. Okay, 9 volt. So now we'll go for the next, which is minus 615. Minus 6, 1. This will be my 5, right? Okay, so our output will come 0 volts. So let's see. Okay, the Vout. So it's coming minus 4, which is also 0 volt only. Okay, we'll also check for, if you want, we'll also check for the other states. So 2 plus 1 plus 2. So let's take 3. So 6 volt. Okay. So Vout is 5.99. That's 6 volt. Okay. So our next part is to design a subtractor circuit. So in subtractor circuit, the V1 voltage will be given to the inverting terminal and a V2 supply will be given to the non-inverting terminal. So the output will be VO is equal to V2 minus V1. So the resistors, so the output expression of this circuit will be 1 plus Rf by R2, R3 by R3 plus R1. So minus Rf by R2 into V1. So we'll take resistors as R1 is equal to R2 is equal to R2 10K. So this combination becomes 2. This combination becomes 1 by 2K. So 2 get cancels. So this becomes 1 V2 minus, and 10K by 10K also 1. So V1. So our final output equation V2 minus V1, which is nothing but a subtractor circuit. So we'll also check it for the different combinations. So let's open it on LTspice. I have already designed it. So let's see to it. So this is my subtractor. V1 supply given to the inverting, V2 non-inverting, RF10, all the resistors 10k. So we'll get expression that V2 minus V1. So let's go for this condition, that is V2 will be 2 volts and V1 will be 3 volts. V2 will be 3 volts and V2 will be 2 volts and V1 will be 3 volts. Okay, so let's run this. Our output will be minus 1 volt. So the Vout minus 0.99, which is approximately 1 volt. So now we'll see for the next condition, that is V2 will be 5 volts, V2 will be 5 volt and V1 will be 1 volt. Okay, so the output will be our 4 volt. So let's simulate. So the Vout 3.99, which is approx 4 volts. So this is our end of the practical, and so thanks for watching.